Okay guys, in this video the lovely Mr. B is going to be showing you lots of examples working with parametric equations for your maths. Now this is rather a tricky topic, so take this video slowly. Make the notes, make examples, copy things down and then pause just after the question and see if you can race through to the answer. If you want more examples, then over on my website there are loads of questions just waiting for you.
Parametric equations are an alternate way to write the equations of curves, where they're put in terms of a third variable. Now let's have a look at what we have here. So we have x is equal to 3t and we have y is equal to t squared. So we have x and y for our x and y coordinate, and we have now a third variable t. Now we're going to start off looking at substitutions. So we're going to find the coordinates when t is equal to -1. So this is just as simple as using substitution. So it will get harder though, trust me. So with x equal to 3t, if t is -1, then x is equal to 3 lots of -1, which is -3. Y is t squared, so y will be equal to -1 squared, which would be -1 times -1 is 1. So now we can write down the coordinates. The coordinates are -3, 1. So it doesn't look too hard so far. So we're going to get used to the concept by doing some substitution, and then we'll look at converting parametric equations back into regular equations that you're used to. So let's do another substitution. We have x and y coordinates. X is equal to t minus 2. So when t is equal to -7, we have -7, take away 2, which is -9. We can do the same for y. Y is equal to t squared. So y would be -7 squared, which would be 49. Writing in the coordinate at the end, -9, 49 is the answer. Moving on to the next example. Again, I'm going to take the x and the y coordinates separately. X is equal to 4t. So if t is 3, that'd be 4 times 3, which is 12. Y is equal to -8t, take away 3. So if t is 3, that'd be -8 multiplied by 3, take away 3. So that's going to be -24, take away 3, which is -27. And again, write down the final coordinate combined at the end. For our next example, again, take x and y separately. X is equal to -4t. So if t is -6, that's -4 lots of -6, which altogether will give us 24. Y is equal to 3 over 2t. So when t is -6, that'd be 3 over 2 lots of -6, which is 3 lots of -12. And we can simplify by dividing through by 3, which will give us 1/4. So our final answer is 24 and a -1/4. So now we'll do one last quick substitution example. So x is equal to t plus 1 over t take away 1. So that's going to be -1 plus 1 over -1 take away 1. Now that's going to give us 0 divided by -2. So we're going to put 0 on. Because say, how many -2 is going to 0? Well, 0. Then move on to y. We have 7t. T is -1. Y is going to be 7 multiplied by -1, which is -7. So the final answer is 0, -7. Now, what's more difficult with parametric equations is combining them together to get one single equation like used to. Now, again, we're going to take the two equations separately to start. We've got our x and our y coordinates. And what we're going to do is rearrange these to make t be the subject. Then when the t and subject are both, then we can combine them together. So if x is equal to -2t, if we divide both sides by 2, we'll get x over 2 is equal to -t, and then we can deal with a negative symbol, just change the sign on both sides. So t is equal to -x over 2. So we're just rearranging equations. Do the same thing with y. Y is equal to 3t squared. Divide both sides by 3. And to get rid of t squared, we're going to square root both sides. So t is equal to the square root of y divided by 3. But now we've got two things that are equal to t, therefore they're equal to each other. So -x over 2 is equal to the square root of y over 3. So now they're combined, but that is not a form that you're used to. So we want to kind of make it into a y equals, like you'd normally see when you draw a line. So how can we do that? First thing we're going to do, let's get rid of the square root sign. Let's square both sides. And then to make y the subject, we can multiply both sides by 3. That will give us y is equal to 3 lots of the bracket. Now, it's looking more like what we're used to, but we're going to want to expand the bracket now. So just square the numerator and the denominator. That'll give us x squared over 4. Then we can multiply the bracket by the 3. That's going to go to the numerator. So y is equal to 3x squared all over 4. An alternate form of that is just writing 3 over 4 as a fraction by bringing the x squared out. And as long as the x squared is on the numerator, you can bring it out like that. So y equals 3/4 of x squared. That's now looking more like a line you would plot. And it's squared, so we know this is going to be some kind of quadratic. So it's a little bit clearer now. So essentially, we're doing 3 lots of rearranging. We're rearranging the x-coordinate to have t be the subject. We're rearranging the y-coordinate to have t be the subject. Then once we combine them, we rearrange it to make y be the subject. And this is also going to explain why we're kind of using the t, the third variable. Because if you're trying to find what x and y are, the last 5 questions are really, really easy because we just substituted in the t. Now imagine you're finding a pair of x and y coordinates from the full equation, y equals 3/4 x squared. That's going to be much more difficult maths to do than a t squared and multiply by 3. We've got a 3/4 in there. That's a much more difficult substitution. And that's only finding y. We don't have this with x being the subject. So if you have a y coordinate and want to find an x coordinate, then you're going to have to do a lot of rearranging first. So again, parametric equations are a lot easier to substitute into, usually. So let's have a look at some more examples. So again, take the x and the y coordinates separately and rearrange them to make t be the subject. So if x is equal to 1/3 of t, that's the same as saying t over 3. And we'll just move the t onto the numerator, which means we want to multiply by 3. So if we do that, we're going to get 3x is equal to t. Let's do the same thing with y. So y is equal to -8 t squared. So again, moving that to the numerator might be helpful because now we can see we need to multiply through by 8 or even -8 to speed it up. So let's do that. Let's multiply through by -8. We're going to get -8y is equal to t squared, and then take the square root of both sides. And now we've got 2 expressions equal to t. We can combine them, and that gives us 3x is equal to the square root of -8y. So let's rearrange now to make y be the subject. So let's square both sides. So if we square both sides, we're going to have 3x squared is equal to -8y. You might want to expand the brackets, so make sure you square the 3 and square the x. And then what should we do next? Let's divide by -8. So now we've got an expression for y. Y is equal to -9/8x squared. We could turn 9/8 into a mixed number. That might make it easier. So that'd be y is equal to 1 1/8, rather -1 1/8 x squared. But if you prefer, you can just keep it as a fraction and write 9/8 x squared. Doesn't matter if it's a fraction or a mixed number. Usually a mixed number is better for a final answer, and a improper fraction is better for the next stage of working out if you're doing something else next. Always look out for the exam telling you which version to write. For the next question, we have x is equal to t plus 3 and y is equal to -1/5 t squared. So the x is equal to t plus 3. Seems pretty easy. Take 3 away from both sides. The y is going to be a little bit more complicated. We might want to do straight away is just write it as -t squared over 5. And then we want to multiply by -5. It'll give us -5y is equal to t squared. So now we need to square root both sides to get t on its own. Now we have both in terms of t. We can combine them together. They're both equal t, so they're equal to each other. So x minus 3 is equal to the square root of -5y. So first thing to do is going to be to square both sides. Now it looked like that x minus 3 was really easy, but now it's formed a quadratic equation. So when we expand this, we're going to have to make sure we've got all 4 terms of our expansion. X squared, x times -3 will be -3x, and we're going to have 2 of those, so it'll be -6x. -3 times -3 is going to give us a 9. Then we want to divide both sides by -5. And now we've got an expression equal to y. For a final answer, we might actually want to divide by 5. And remember, this is negative as well. So we're going to have -1/5 x squared, because if you divide 1 by 5, you get 1/5. Then we've got a double negative for the 6x, so we plus 6/5 of x. And then we have minus, because again, we're taking the negative of all 3 terms, because we've got the negative symbol on the outside. It would be -9 and we divide that by 5. And you'll notice for the process of dividing by 5, I haven't actually divided anything by 5. I've just written over 5. I could convert two of the terms into mixed numbers, but I'm going to leave them as they are. But now you can see something that looks more like a quadratic. And you can even get an A, B, and C coefficient out of this to use the quadratic formula if you needed to as a next step. So again, just getting it to be y equals isn't enough. Try and get it into a kind of regular line equation. For a quadratic like this with 3 terms, if it's linear, try and get your y equals mx plus c. So let's try the next example and start off rearranging x and y. X is equal to 3t. So we'll divide both sides by 3. We're going to get x over 3 is equal to t. Might be better to write it as a third x perhaps. We'll see when we get on to the next step. For y is equal to 4 over 8t. So to rearrange first, why don't we multiply by the 8t? So that'll give us 8yt is equal to 4. Now we want to make t be the subject. So we need to divide the 8y now to get it on its own. So t is going to be equal to 4 over 8y. Now they're both equal to t. We're going to get a third of x is equal to 4 over 8y. We want it to be y equals, let's multiply both sides by 8y. That'll give us 8y over 3, like this. So again, we multiply, just pop it on the numerator. And we can even include the x there as well, actually. Now we can multiply both sides by 3, which will give us 8xy is equal to 12. Notice so I interchange the x and the y. They can be either way around. Multiplication, doesn't matter which order you do them in. Now again, we want y on its own. So let's divide by 8x. Well, let's do it one at a time. Let's divide by 8 first. That gives us that xy is equal to 12 over 8. And we can simplify that by dividing it by 4. That's going to give us 3 over 2. Then we can divide both sides by x, giving us y is equal to 3 over 2x. And so if we divide by x, it's got to go onto the denominator. What we can't do here is we can't write 3 over 2x like this. If we kind of move x like this, then you're implying that it's actually on the numerator. So you can only actually kind of interchange the letter being on its own or on the numerator if it's actually to do with the numerator. So on the denominator, it's got to stay where it is. Moving on to our last example, you can see now the x-coordinate is quite a bit more complicated. So let's do the y-coordinate first. So y is equal to 4t. So divide both sides by 4. Y over 4 is equal to t. Or we could write a quarter y is equal to t. They're both the same thing. Multiply by a quarter, divide by 4. No difference. So now we can look at x. X is equal to t plus 1 over t plus 1. So let's get rid of the fraction first and multiply both sides by t plus 1. Then we get all the t's on one side because what we want to do here is try and take t out as a single factor. Multiplying at the brackets is going to be helpful as well. So we're going to have xt plus x. Then we take away the t, we'll have xt. Take away the t plus x equals 1. And you'll notice I didn't put the minus t at the end. I popped it in the middle because I want the t terms next to each other for when I factorise. And having the plus or minus terms in different order isn't going to make a difference. Let's take t out as a factor. Xt without the t is going to be x. And negative t without the t is going to be negative 1. Now, I want to divide by x minus 1 to get t on its own. But to divide that, I'm going to divide all 3 terms by that. So let's get the x on the other side before we do that. Let's take x away from both sides and then divide both sides by x minus 1. The t is equal to 1 over x divided by x minus 1. Now we can combine the two terms. So we're going to have 1 minus x over x minus 1 is equal to a quarter y. And we want to have y equals, so we're going to multiply both sides by 4. So you'll need to multiply the numerator by 4, the denominator is going to stay as it is. Now, in our last set of questions, these work very similar, but the third variable isn't t. The third variable here is theta, so it's the angle. So you can imagine that maybe in the previous questions t could stand for time. This is going to stand for the actual angle in the question. Now, the way we combine these together is a little bit different. Now, you'll see there's trigonometry involved with the x and the y. It's a little trick we can do. In trigonometry, there's something called a trigonometric identity. And the most basic one is that sine squared theta plus cos squared theta is equal to 1. And so we need to use this identity to combine these two equations together. And so our first step is going to be rearranging x and y like we've done for the last 5 questions. What we're going to do is try and get the sin and the cos section kind of on its own so we can substitute. So let's look at x first. X is equal to 3 cos theta. So if we divide both sides by 3, you get x over 3 is equal to cos theta. And actually, that's all we want, because if cos theta is x over 3, cos squared theta is going to be x over 3 squared. So we've substituted in our first part, but we still need the sine part done, so let's do that next. So y is equal to 6 sine theta. Divide both sides by 6. Y over 6 is equal to sine theta. So if sine theta is y over 6, sine squared theta is going to be y over 6 squared. And now we've substituted x and y into the identity, and we've effectively combined together our two parametric equations into a single thing. Now, this again isn't recognizable yet for something you might see. So let's try and expand the brackets and see what we get to. So if you're squaring a fraction, square the numerator and the denominator. There's y squared over 36 plus x squared over 9 is equal to 1. And then let's multiply through by the largest of the denominators. Let's multiply by 36. So multiply and divide by 36 cancel out. Then for our next one, we're going to get 36x squared over 9. And we can actually simplify that. 36 over 9 is going to give us 4. So let's write this out in a little bit more detail so you can see what's going on. With the y's, we have 36y squared over 36, which simplifies to y squared. With the x's, 36 over 9 gives us 4. Now, we've multiplied these two terms by 36. We also have to multiply 1 by 36. And now you can see something that resembles the equation of a circle. And you might just want to clean it up at the end and put the x-coordinate first, which you tend to see, but it shouldn't be too much of an issue. So we've swapped around the x and y coordinates there. Now, what this actually is rather than being a circle, because one of the letters, the x, is being multiplied by 4, this means it's an ellipse. It's a stretched circle because the x-coordinates being multiplied by 4, stretching the circle. So one's kind of width is going to be 4 times wider than the other width. So moving on, for all these questions, again, we'll be using the trigonometric identity, sine squared theta plus cos squared theta is equal to 1. So we're going to take x and y and rearrange to get sin and cos on their own. X is equal to negative a quarter cos theta. We could have written that as a negative cos theta over 4. What we want to do, we want to multiply by negative 4. That will give us that negative 4x is equal to cos theta. And let's just free up some space there. Now let's do the same for sine. So y is equal to sine theta. Well, we have sine theta on its own already, so there's nothing we need to do here. So now we're going to substitute. So firstly, let's substitute into sine theta. So sine theta is equal to y. So sine squared theta would be equal to y squared. Then we'll look at cos theta. If cos theta is negative 4x, then cos squared theta is a square of negative 4x. So now we expand the brackets. So negative 4 multiplied by negative 4 is going to give us 16, and x times x is x squared. Now, like the previous question, we've got something usable straight away. And again, for your last step, perhaps put the x term first, as we normally see. So there's our final answer. The next example, we have x is equal to negative sine theta. So all we want this is to be equal to sine theta. So multiply both sides by negative 1. We'll get negative x is equal to sine theta. Looking at y is equal to a 7th cos theta. Multiply both sides by 7, and we get 7y is equal to cos theta. So notice the rearranging in this case isn't actually too difficult. The difficult part of this question is remembering and using the trigonometric identity. Sine squared theta plus cos squared theta is equal to 1. So for the sine squared part, sine theta is negative x, so sine squared theta will be that squared. Then the cos theta 7y, the cos squared theta will be 7y squared. Expand the brackets, negative x times x is going to give us x squared. 7 times 7 is 49, y times y is y squared. And so we've got our final answer straight away. You might notice in this question that the sine and cos were the opposite way around. This time sine was part of the x-coordinate. So that meant that I didn't need to do the extra step of rearranging at the end. Our next example is a little bit more complicated, with x having a plus 7 on the end and y having a plus 6 on the end, in addition to the usual sin and cos. Let's try and do the same rearranging. So my first step with x is going to be to take 7 away from both sides. That'll give us an x minus 7 is equal to 7 cos theta. So now let's divide both sides by 7. So if we just do the individual terms one by one, rather than do the whole thing, because I could just write the whole over 7, but I can see the negative 7 is going to go into it. So I could actually simplify this. So we're going to have a 7th of x take away 1 is equal to cos theta. Let's have a look at sine. Y is equal to 7 sine theta plus 6. So let's take 6 away from both sides first. And then we can divide through by 7. So we're going to have a 7th of y take away 6 divided by 7. So unlike the 7 divided by 7 in the previous bit, I can't actually simplify my fraction here. That's still equals sine theta. So again, remember the trigonometric identity. Sine squared theta plus cos squared theta is equal to 1. So let's look at the sine. Sine theta is equal to a 7th of y take away 6/7. So all of that is going to be squared. Then the same thing with the cos. Cos theta is a 7th x minus 1. So we square it, we get this. So now we need to expand the brackets. Now this is going to be much trickier. You might not expand it fully and, maybe even draw the arrows to show what's multiplying by what. I'm going to try and do it mentally. So we're going to do a 7th y multiplied by a 7th y. It's going to be 1/49th of y. Then we're going to have the 7th multiplied by the negative 6/7. So that's going to give us 6/49 or negative 6/49. I've got the same bracket twice. We're going to have 2 of those. So we've got 2 of them. It won't be 6/. It'll be 12/49. Do the same thing with the x's. So 7th x multiplied by 7th x is going to be 1/49th of x. It should be squared, actually. Let's do the same thing to the y. Then we're going to have the 7th multiplied by negative 1, which will give us negative 1/7. And it's the same bracket twice. We'll end up with 2 of them. Now, I've actually missed a bit out here because we have the third term as well. We're going to multiply the number section by itself. So we're going to have the 6/7 multiplied by 6/7, which is going to give us a 36/49. And then the negative 1 times negative 1, which is going to give us a positive 1. And well, honestly, I did forget about those numbers. Popping on the end like this can be helpful because now we've got to combine them together so they're next to each other. That makes that a little bit easier for us. And I think before I'll do that, I can see that a lot of these fractions are over 49. So what we want to do here is multiply everything through by 49 to simplify it. Because 49/49 is going to give us 1. So let's do that. We're going to have y squared take away 12y. Then with the x, we're going to have x squared take away. Now this one's over 7. It's not over 49. So what we could do is we could say, well, we're going to have 49 times 2 all over 7x. And 49 divided by 7 gives us 7. So the numerator is going to read 7 times 2, which will give us 14. So it's going to be 14x. Then we're going to have 36 plus 49 is equal to 49. So we can add those together. 36 plus 49 is 85. And what we're going to do is take that away from both sides to get it on the outside, which means we're doing 49 take away 85, which is negative 36. So its final form, if we write the x's first, we're going to have x squared take away 14x plus y squared take away 12y is equal to negative 36. Best thing to do actually is if we write it on the other side, so it'll be a positive 36, we can make it equal to 0, and this is one of the forms of the equation of a circle that you can see. So we know that what we have here is actually a circle. What you might want to do as a final step is to get it into the other form of the equation of a circle, so complete the square. Negative 7 times negative 7 will give us an extra 49, which we need to take away. Complete the square for y. Negative 6 times negative 6 is 36. We need to get rid of the extra 36. Now we can see the negative 36 and the positive 36 are going to cancel out. And then we want to add the 49 to both sides to move that over to be a representation of the radius. So altogether, the equation of a circle is x minus 7 squared plus y minus 6 squared is equal to 49. And now we know the centre of the circle is the coordinate 7, 6, and the radius is the square root of 49, which is 7. And hopefully from this, you see the advantages to both forms. If you wanted to find particular coordinates around the circle, then substituting into the parametric equations is going to be the easiest. You can even substitute in an angle. So you could say, well, what's the x and y coordinate going to be at 23 degrees on the circle? And you'll get answers for that. Whereas with the proper circle equation we've just written, we get the centre of the circle and the radius. So there's positive and negatives to both forms, and you'll use them in different scenarios. Moving on to our last example, it looks like to be another equation of a circle. We could change it from the parametric form into a more common algebraic form that we're used to. So let's look at x first. X is equal to a 6th sine theta plus 6 So let's take 6 away from both sides and then multiply both sides by 6. And now we have sine theta on its own, ready to substitute. The same with cos. Let's take 8 away from both sides, multiply both sides by 6, and now we have cos theta on its own. We're ready to substitute. What are we substituting into? Again, we need to remember we're using sine squared theta plus cos squared theta is equal to 1. So sine is equal to 6x minus 36. So we need to square that because we want sine squared. Cos is equal to 6y minus 48. So cos squared will be that squared. So let's expand the brackets. So 6x multiplied by 6x will be 36x. And then 6x multiplied by 36 is going to give us 216x. So we're going to have 2 of those because we've got 2 of the brackets. That'll be 432x. Then we're going to have 36 times 36, which is going to give us 1,296. So getting some quite large numbers here, but we should be able to divide these through and simplify them later on. Same thing for y. So 6y times 6y is 36y squared. 6y times negative 48 will give us negative 288. We're going to have 2 of those, negative 576y. Then 48 times 48 is going to give us 2,304. And it's all equal to 1. So what we want to do is try and sort out some of the mess with these numbers. And what we probably want to aim for is to get kind of 1x squared and 1y squared. And I think it's probably a good bet that 36 is going to go into all of these. So let's try dividing through by 36. That will give us x squared. So 432 divided by 36 gives us 12x. 1,296 divided by 36 gives us 36. So these numbers are becoming much more reasonable now. 706 divided by 36 gives us 16. And 2,304 divided by 36 gives us 64. But then what happens is, the one at the end, that also is divided by 36. So now we can write it in the form we'd write for a circle. So x squared, take away 12x, plus y squared, take away 16y. And then we want to do the 36 plus the 64, which is 100, and we want to take away from that the 1/64th, which is going to give us 99 and 36/64 equals 0. Now that number at the end looks like a bit of a mess. Let's see what happens when we complete the square and get it into the usual circle equation. So we have x minus 6 all squared, and we're going to have a spare 36 to take away. Then we're going to have y minus 8 all squared and an extra 64 to get rid of. Then we've got our 99 over 63/64. So let's combine all those terms together. So for our final equation, we're going to have x minus 6 squared plus y minus 8 squared. Then we need to collect together our terms. We've got a negative 36, take away 64 is negative 100, and then we're adding on 99 and 36/64. Now, altogether, that's actually going to end up giving us a negative 1/64, which on the other side will be 1 over 64. So initially, collecting all terms together gave us a bit of a mess, but then putting it back into the brackets by completing the square, we've kind of undone the same mess with the similar numbers. So now, for our final answer, we know what the centre of the circle is going to be. It's going to be the coordinate 6, 8. And we know the radius of the circle. It's going to be the root of 1 over 64. So it's going to have a radius of 1/8. But again, there's no mention of angles here, and that's where the parametric form is useful, where we can get coordinates on the circle depending on the angle that it's at.